Okay, so let me unfreeze my screen here. All right, so our learning target today is to find the area of regular polygons, and we've been doing that pretty over the last day or two. So give me a second, guys. What I want you guys to do now is.
So sorry.
Bless you.
I had a little sneeze.
Bless you. Okay. Yeah, we had a kind of an interesting sneeze just now. All right. So here's what I want you guys to do. I want you to see if you guys can find the area of the shaded region. Okay. So I want you guys to see if you can't take this on. Okay. So your job is to find the area of the shaded region. Now, I want two different things. Okay. And I want you guys to see this. I want the exact answer. The exact answer are going to involve probably square roots and probably pi in it. You guys understand? Not the food, the letter, the number, right? And then the rounded answer is going to be just putting that all into the calculator and seeing what we get. Sound good? So we want an exact answer, and then we also want the rounded answer that's crunched in the calculator. Now, while you're doing that, I want to make an announcement. Anything, I haven't put grades in, but I will be putting in this afternoon. So I think we have a when was the Delta math due today? 8. So I won't put that in. But I will be putting in 447, right? That's due today, right? Yeah. So I'm going to be putting that in today, and I think there's another one I'm going to be putting in. So I'll be putting in 2 book assignments, okay? So make sure you get that done. Other than that, go ahead and give this thing give a try, and we'll get going on this. I got to get a pencil for a couple kids here. Area of regular polygons. You're good. Now, guys, I know there is a never mind.
What?
I know there is a lot of like loose leaf paper and everything. It might be smart to get yourself like just a folder like this to put it in, like with all our projects. Does that sound good? So, does anyone need one? Or are you good? Just what Kaylee has is really smart, I think. Yeah, and you got some Pythagorean theorem. Yeah. Look at that. You guys are way ahead of the teacher here. Now, you guys need to remind me to stop sharing, or else there will be a 8-hour geometry video being posted. So, yeah, I mean, they're going to have. No, remind me. Rachel, remind me. I can trust you, right?
No.
I'll pay someone Jag bucks to remind me. First person to remind me at the end of class, I'll give them 10 Jag bucks.
10 Jag bucks? I haven't gotten mine, and I tweeted today.
Oh, we got the Jag book. No, it has to be at the very end because I can't stop it now, Chris. That doesn't help me. I've already forgotten. At the end of the day, at the end of the class. Not the end of the day. Don't do that. Don't come in here after 7. That would be.
I'll come here around.
That would be non-helpful.
X is 4.5. Then we can find the Apothem. Super 360 degrees. And then we want to put divided into 6 equal sections. So it'd be 60 degrees. And then when you put a sauce in it, there's another 60 degrees. So then that makes it a 30 degrees.
What's that?
So then those shines of sauce.
How's it going, guys? Okay.
I forgot how to do that.
For area of
Alright, so then, the pot needs to be 9.
Are you the choir kids?
Yeah,
So then
that's
that'd be-
not.
The singers are here. Okay, that's good. This will be good for you.
so that's-
Okay, good.
Okay, I'd like to wait. I'm waiting for my Jagbuck girls. Who are my Jagbuck girls? Sophia, Caitlin, and Tess.
Wait, there's one more.
That's called will.
You stress me out so much.
Right.
So equal level. That's also a radian. Radius.
Radiuses.
Radiuses.
Radii.
Radii. Thank you. So that's also not 60 degrees. So it's not the altitude.
Apothem. So the Apothem is an altitude.
You can draw that. That's where I don't.
Why is this like
Or wait a minute.
I got you. I'll wait.
I know the answer.
So it's gonna be.
Ladies, we're finding the area of the shaded region on that thing after you give some Jaguar bucks out.
We are just halfway to presents. Hey, can I?
I need my
Brady,
Jagbuck.
we're 20.
I'm 20 with
That's
you.
racist.
Honestly.
It's because it's black.
Exactly.
Black dress on. I saw her like 5 seconds ago.
I'm 20 with Isaac.
Not turning dress on.
I'm pointing with Nick.
I'm 20 with the guy who always wears the Broncos sweatshirt. You know what I'm saying? I know that's that last year. He wears all the time.
I'm pointing with Pickle.
Hey, how much longer should I give you guys before we start going over this? Obviously, our Jagbuck girls are gonna probably have to catch up, right? Let's do this. Let's do 2 more minutes, and we're gonna start going over it.
Alright, so we know
Black shirt, black sweatpants.
we don't know the person.
Like pretty shirt.
We know the
Oregon Duck for sure. Definitely.
No, he has black shirt on.
So 1.5 years.
Because it's a regular.
Yeah, 30, 27.
I think I did this.
So I don't know what the exact answer would be. I don't know what
I say it's at least 9.
It's gonna have a pi. It's gonna have a square root.
Really?
It may not have a square root, but it's definitely gonna have a pi. All right. Now, there are multiple strategies here, ladies and gentlemen. Would anyone like to suggest maybe so before we find the area of the shaded region, we probably want to look at the big picture, the big strategy. Someone raise their hand and tell me, what is a big strategy that you're going to use to find the area of this? Xavier, what are you going to do? Right, and I think that now there are other ways to do it. I kind of was just kind of walking around. I heard students like doing equal parts and things like that. That's fine, but I think a good strategy, whenever you see shaded regions, like 2 shapes inside each other, a great way, in this case, the Pentagon is inscribed in the circle. A great way to do this is, take the area of the bigger shape, which is the circle, okay, and subtract off the area. So the area, I'll put area of circle minus area of hexagon. Okay. So I think that's a good strategy, because when you do that, if you take the entire circle and then you subtract off the hexagon, does everyone understand that all that's going to be left over is this shaded region? You guys see that? Okay. So the first thing we need to talk about is the formula for the area of a circle. This is Xavier told a funny joke this morning. He said, "Can I repeat your joke, or do you want to repeat it?" Xavier said, "Hey, Mr. Roden, what's the formula for the area of a circle?" And I said, pi r squared. And he yelled at me, saying, "No, pies are not square. Pies are round." Well, that's a pretty good joke. Okay. All right. Now, okay. So, but it is pi r squared. So pi times radius squared. Now, if I get some time, this is a magical formula that most kids have no idea why that's true. Okay. This is just some kids memorize this. They think like it's a magic or aliens brought this formula to us. So we probably should understand where this formula comes from at one point or another. There's just not enough time in the day sometimes. But we probably should derive this little formula right here, because this is a pretty important formula we use a lot, and most kids have no idea where it comes from. Okay. Now, the area of a hexagon, what's the formula for the area of a hexagon? We learned that yesterday. So our choir people and other people who aren't here, world travelers or whatever. Yeah, so that's 1/2 AP. Okay. So that's the general thing we're going to do. Okay. Now let's start plugging numbers in here. So we all know pi. We don't want to put 3.14 in for pi. Pi is not 3.14. Pi is 3.14 is a close rational number that's close to the number pi. Pi is pi. Okay. The ratio of the circumference over divided by its diameter. But pi is pi, so don't stick 3.14 in there. Okay, that's not pi. That's a number close to pi. Well, an r, that's 9, right, guys? So 9 squared. So looking at this one, the area of the circle is going to be 81 pi. You guys see that? So that's going to be the area of our circle. Now, this is going to be part of our exact answer. Okay? Now, the next thing we need to do is we need to get an answer for the area of the regular hexagon. Okay, now I'm going to extend another radius out, a radii like this, just to kind of see it. So this is 9, and then I'm going to put this little special thing we learned yesterday called the apothem. Okay, the apothem is basically just a height of one of the triangles inside. Okay, and so that's what this whole apothem, this is A in the formula right here. This A here is this A here. You guys see that? So we need A, right? We need the entire area. We need A and we need P. We need perimeter. Okay, you guys with me on that?
Yeah.
Now, I know that one of these sides is what, 4.5, right, guys? Because this is a special case with hexagons. But let's just kind of not use that, because that's just the hexagon. So we know this is going to be 4.5 from here to here, but let's find it without just knowing that it's just that this is an equilateral triangle, okay? Because that's only for hexagons. So if we're looking at this triangle right here, I'll make it in blue, okay? So what I want to do is I want to use this little blue triangle here, this little right triangle right here, okay? So and we're doing exact stuff here because what is this angle right here, guys? What's this angle going to be right here? That's going to be a 30, right? And so this has to be a 60 and this has to be a 90. So this is forcing us to use our 30, 60, 90 rules. So what we basically have is we have an X and we have an A. You guys agree with me on that? Okay, now I'm going to go over here. A is going to be our long leg. Does everyone understand that, of our 30, 60, 90? A equals the long leg of the 30, 60, 90 right triangle. And I'm purposely making you do this because I think we've already forgotten this. And this is a really important thing in trigonometry, is remembering these right triangles, these 30, 60, 90s and 45, 45, 90s, because we use them so much later down the road. Okay, so A is the long leg. So what is the formula and then we know 9 is the hypotenuse, right? Yeah. 9 equals hypotenuse. And so we know X is equal to the short leg. Now we already know the short leg in this specific example is 4.5, but let's see if we can figure that out. So what piece of information do we have? We have hypotenuse, right? So we know hypotenuse is equal to 2 times the short leg in a 30, 60, 90 right triangle. You guys with me on that? Okay, so in this case, hypotenuse is 9 equals 2, and then x is our side. Divide both sides by 2, right, class? And so we get x equals 9 over 2, or 4.5. And we already knew that. Okay.
Yeah.
Now, so what do we have here? We have 1/2. Okay, now we need to figure out a. Okay, so we'll use x in a minute. Now let's figure out a. Okay, so how do we figure out a? Well, that's going to be the long leg, right? Now, what's the formula we have here, guys, for long leg? I'm going to erase this. You could use the Pythagorean theorem, absolutely, or we could use the long leg formula, right? What's the long leg formula, guys? Let's use the long leg formula, guys. I love the long. Okay, Martin, what's the long leg formula? I hear you saying it there.
S square root of 3.
Okay, so long leg, in this case, a is our long leg, equals x times the square root of 3, or a equals x, which is 9 times 4.5, sorry, my bad, times the square root of 3. Okay, it's not h times the square root of 3. All right, so that's our a. So we could say this is 4.5 times the square root of 3. Now, the last thing we need to do is find p. You guys see that? Okay, how would we find p, guys? How would we find p? Multiply 4.5 times 12. Why would we do that, Sam? I like your thinking there. Why would you do that?
Because there are 6 sides, and we just found half of one side, so if we
Right.
multiply it by 12, we get all of those.
Right. Does everyone see that we have, this is 4.5, but that's just half of one side. Remember, P stands for perimeter, all of it. So what is 4.5 times 12? What is 4?
54.
So this is 54. Now, this is the exact answer right here. Does everyone see that? Now, we could simplify this a little bit more if we wanted to, right? 81 pi is done. There's nothing we can do with 81 pi. But I guess if we really wanted to simplify it, we could take half of 54, right? And then we could multiply that by 4.5. So half of 54 is, what is that? 27. And what's 27 times 4.5? 121 point what, George?
0.5.
So this is 121.5 square roots of 3. So this would be your exact answer right here. Do you guys see that? Simplified as much as possible. Okay? You guys with me on that? White, you have a question?
Do we have to take 1/2 from 4.5 though?
I took 1/2 of 54.
You
And
only do it for one number?
yeah, just one number. Yep. Because you could rewrite this as 1/2 times 54 times 4.5. And then that's commutative, which means you can do it in any order you want. Sound good? Yeah, good question. Okay, yeah, you're not distributing. The reason you're not distributing is there's not a plus sign in there, right? Austin, does that make sense?
Yeah.
Why does that make sense?
Yeah.
Okay. All right. Now it's just number crunching time, right? So you probably want to, and you want to use the pi symbol. You don't want to use 3.14 because the pi symbol is going to be more exact. And so now area is approximately equal to what? 44.1, something like that?
Yes, 44.
44.0 centimeters squared. Okay, you guys see that? Yeah.
Okay,
So-
it's 44.
But we're all agreeing about 44, right? Okay, good. So a good strategy, a more accurate answer always leaves square roots and pies into the very last minute. You guys understand that? You don't want to actually put 3.14 in here because you're not going to get as an accurate of an answer, especially if you were going to round this to bigger, more numbers to the right of the decimal. Questions? Okay, now let's look at a couple other regular polygons that don't involve 30, 60, 90, and 45. So this is our friend, the Pentagon. Okay, so this is a regular pentagon. Okay, so everyone write that down. So this is, and I want you guys to just sketch this. Do your best job.
I refuse to sketch it.
All right. Now, Regular pentagons. I mean, obviously, I think it was Ed. Who told me they were at the Pentagon? I can't remember. Kaylee did.
I did.
Kaylee did. So Kaylee said, "You've been to the Pentagon in Washington D.C., Kaylee?"
I like walked right by it.
Walked right by. And if you look at the obviously, if you look at the top of it, it is a regular Pentagon. It used to be. I don't know if it still is. Yeah, it's like a Pentagon inside a Pentagon, right?
There's a big Pentagon inside.
Yep. So if I've been told it's the largest office building in the United States, or in the world, but I don't know if it's still true. Okay, so how would we do this? Well, we're going to use the same concept here, class. So we're still going to use our 1/2 AP, right? So let's kind of take a look at this really quick. I'm going to put my center point, and then I'm going to put my radii in here, and I'm going to put all my radii in. Okay. Remember, we could put it around a circle if we wanted to, or we don't have to. So I'm going to put all my radii in, my 5 radii. You're going to have the same number of radii as the sides. Okay? Notice these are not diagonals. They are radii, right? Okay, now, the next thing we're going to do is we need to know what these are called central angles, so the angles that are formed by the radii, 2 radii. What are each one of these central angles going to be?
72.
How are you getting 72, Martin?
Because if you take 360 and divide it by 5, you'll get 72.
Okay, do we all agree 360 divided by 5 is 72? So each one of these, ladies and gentlemen, are going to be 72. Now, here's the problem here. Remember, though, we need the apothem. So I'll make my apothem in green right here. I'm going to drop an apothem down here, right? So this is, remember, right away, you're going to notice you don't have an equilateral triangle. Okay, you have an isosceles triangle because you have 2 radii, but you don't have equilateral here. Now, what is this angle right here going to be here?
72.
Half. That's going to be 36 degrees, right? You guys see that?
Yeah.
Now, what is this angle down here going to be over here? If this is 36, what does this have to be here?
21.
What is it?
Uh,
What's 36?
54.
What?
44.
I think 54. It sounds good.
54.
44 or 54?
54.
54.
Right on. 54.
Okay. So, guys, we do not have a... Xavier, what's up?
It is 54. I checked. It is same.
Okay, there is no such rule for a 36, 54, 90 right triangle. There's no rule for that, guys. So we cannot use a rule like, so now the only thing we can use here, ladies and gentlemen, is trigonometry, right? Now, if we're looking at this triangle right here, so I guess the point here is certain regular polygons make you use the 30, 60, 90 rules and the 45, 45, 90 rules. But some of them only allow you to use the trigonometry. So notice, guys, right off the bat, I didn't put an equal sign. I put an approximately equal sign because this is going to be a completely rounded answer. Okay, guys, with me on that? So what are we going to do here? Notice, guys, all we have is one angle measure. Okay, we don't have any other numbers inside this blue triangle.
Yeah, we do.
So someone raise their hand. Martin's been doing a fantastic job. Someone help Martin out a little bit. Someone help me out. What other number can I put inside this blue triangle? Come on, guys.
7.
Chris, where are you getting 7 from?
From the 14.
Okay, this is a regular polygon, which means by definition all sides are the same length. The apothem acts as a perpendicular bisector. You guys understand that? It's also an angle bisector. So the apothem is going to bisect this side. So Chris has appropriately figured out that this is going to be 7. Okay, you with me on that? Now, right off the bat, we got area equals 1/2 A. I don't know A, but I actually do know perimeter, right, guys? What is the perimeter? We can do the perimeter right now. What is it?
70.
What is it, George?
70.
How are you getting 70, George?
Well, 7 would be 1/2 of this side, and there'd be 5 of those. So if you multiply, 1/2 would be expressed 10 times as a perimeter. So 7 times 10 would be 70.
Perfect. 70. You guys all see where George got that from?
No.
What's 14 times 5? 70. What's 7 times 10? I like the way George thought of it. He's saying, okay, half of it's 7, but now I know I'm going to have 10 little chunks of 7. Okay, I like that, George. Good thinking. Okay, now here's the deal. Now we need to figure out A. We know this side of the blue triangle is 7. We're trying to figure out A, and we have a 54-degree angle right here. What trigonometry SOHCAHTOA rule should I use to figure out A, class? I should use tangent. So tangent is opposite over adjacent. So tangent of 54 equals A over 7. Okay? You could also use 36 if you want but you'd use tangent there also, right? Okay. Now, multiply both sides by 7 to get A by itself, so we get 7 times the tangent of 54. Now, what you want to do now is you don't want to put a number in there yet. So now our area is approximately equal to 1/2, or you could do 0.5, times 7 tangents of 54 degrees times the perimeter of 70. Now you want to put it into your calculator and make sure you're in degrees. So go ahead and do that, everybody. Make sure you're in degrees and put this in just like this. Remember, we're multiplying by 7, but we're taking the tangent of 54. Okay, you see that? It absolutely will be on your next test.
Wait, our next test was
After spring break, like 2 weeks after spring break. Okay. So it's going to be called a trigonometry test. And it's going to involve everything we're doing right now. Okay. It's going to be a pretty massive test. What do you got? Okay, Xavier's got about 337 point what? Okay, just give me a thumbs up if you agree this is a pretty good answer that you're getting. You're not just agreeing with Xavier because he's smart. You're agreeing with Xavier because your computer is saying the same thing as calculators. Okay, you guys with me on that? Okay, so what I want you to do right now is I want you to see if you can figure this problem out by yourself. Octagon. So guys, Xavier yesterday kind of, I don't know, maybe Xavier kind of was having a bad day or something. He didn't have good breakfast or something. So Xavier was he was a little edgy yesterday, and he asked me, why would you ever want to use this? Okay, why can we use this? Well, obviously, an octagon is a stop sign. So now if you get bored over spring break, you could just get a ruler and go back to your local stop sign, and you could figure out the area of a stop sign in square inches. Okay, so don't you want to know how to figure out the area of a stop sign? Okay, so obviously these are very useful things to use. Okay, all right. By the way, I have actually gone up to a stop sign with a ladder and measured it. Because I'm a geometry teacher, I wanted to use it. Okay. There's some really big ones up near Liberty. They're really big. They're so big they have to have 2 posts to hold them up.
Whoa.
They're really nice.
Oh,
Yeah, up near Briargate. Yeah, you know what I'm talking about? Those are some big stop signs.
I always hit those stop signs going to the skate park.
Yep. And they're pretty big, huh?
Yep, they are really big. And some of them have
Flashing lights, yeah. Guys, if I had to recommend it, those are some great stop signs to measure. But sometimes the police think you're taking them down, so make sure you're telling them it's from Matt. Don't mention my name, though.
Or would you? So the whole angle is 45.
So think about it.
How you spell that?
Can have a decimal, Chris.
So it'll be like 2.25.
You are going to have a decimal, Chris. It's going to have a 0.5 in it, right? Yep.
45%. Oh wait, no. So it'd be 15.25.
Sure. You can have decimals and angles, yep.
15.25. No, not 25.
Eddie, what route would we use?
Not 15.25.
Yeah, it's fine.
I don't know. I haven't done math yet.
You should.
No.
How we doing?
It's Jason.
No, it's
Thanks.
gonna be
Xavier, that's really
22.5.
Yeah, I figured. You're also extremely helpful.
I know I am.
Super
Think
helpful.
about it.
Let me help him out. You do it, but try not to make any mistakes.
66.5. No.
67.5.
Yeah. 67.
Jeez.
I literally was off. 67.
Oh, this one's cool because I gave you the radii, not the side, right?
Yeah, that makes it harder.
Mr. Roden, are we rounding to the hundreds or to the tens?
Let's go tenths.
Okay. 6.
Yeah. So you're definitely gonna have to find the sides too, right? Because the other one gave you the sides, so you just multiply it by 5, right? This one I'm not gonna be so nice. You gotta. Don't you guys want a mental challenge this one?
We need a side first.
I got the answer.
I got 9.
You're going to need the side and the apothem, right?
I got the
You're going to probably need multiple trigonometry ratios for this problem.
One side, 11. Let's do it.
What did we do for the last
That's a Jason number.
1/2
You guys understand these are regular though? They have to be regular to do these formulas. Okay, you can't have just a stop sign that's been like squished or something, right?
Good. This is very intense.
Wait, no, this is not. I think I thought. I don't know, yo. What if I do the cosine of 2?
Oh, so that's 10.2.
And multiplying I got the answer,
Yeah,
guys.
that's what we need.
What is it?
Why would I tell you my number?
Because I'm asking.
Yeah, we need to
It's
put it in.
classified information.
I did the cosine of
And 55 doesn't make sense either.
Okay, and then.
Alright, I can help you with my scientific genius.
Okay.
Okay.
What is it?
It's 342.7.
Wrong.
42.7. Oh my god, perimeter. Ah. Oh.
How much more time do you guys think you need?
11.
How about 2 more minutes?
Yeah.
30 seconds. When the big hand gets on the 4, we're gonna roll with this, okay?
Yeah, he asked.
57. And it's not 57. It's
So
57.5.
multiply that by. There's 8 sides.
I did it, guys. I did it.
It's 67.5.
It's 200.
Oh.
It's 67.5.
And then Jack do 8.4 times.
Alright.
I have no idea what the answer is, Xavier.
That should be the same.
I just randomly made this problem. We're gonna do it by democracy,
What'd you get?
which is a terrible way to do math.
And what's the
You ready?
That's what I got.
X is equal
I didn't. I never heard you say that number.
Just type that in as soon as you saw Xavier. Kaylee, how are you doing?
Oh, I remember this. It's pi. You have to subtract it.
rounded.
Well, I got close enough. So. And then what was your decimal? What was your decimal? And what do you got?
I understand.
Yours is slightly more accurate. 'Cause you switched it.
Slightly.
No, I don't think
I would give you like,
And here's the exact.
I'd probably give you a C minus.
Let me check.
I would be the
Let me check with you.
I'd give you like, maybe a C plus.
No, that's not allowed.
And then I multiplied the whole thing by 16.
Okay, so here we go. Now,
He was 0.7 off.
the first thing you want to do is you want to put your radii. Now, I'm not going to do all the radii, but what is this angle? Let me do 2 radii here. Okay, let me do one up here because I don't want to mess up this angle. So guys, what are each one of these angles equal to? If you take 360 divided by 8, what do you get? These are all 45-degree angles. Agree with that? Now, obviously, we're going to have to split this angle in half. So now we're getting into a decimal angle, which is fine. We normally don't use decimal angles, but that's completely fine. So what is 45 divided by 2, class?
22.5.
So it's 22.5. Okay. Now, we know that the radii are 11. Okay. So now we're going to have to find 2 things. We're going to have to find Apothem, and then we're going to have to find X. Okay. You guys with me on that? And so we're finding the area of, I'll just do it in blue, this blue triangle right here. Well, we're finding the sides of those 2. Okay, so just for the sake of it, I always like to use the angle down here, kind of on the bottom left. So what would this angle be down here, guys?
67.5.
So this is 67.5. That's the angle I'm going to choose. You could still use the 22.5 and get the same answers, right, guys? But this is called standard position, and I like to have it that way just because I do so much. Every time I'm tutoring in trig and stuff, you just see it a lot more like this, okay? Upside down, I'm not used to seeing it. Okay, so the next thing I want to do is I want to figure out A or X. So someone raise their hand and tell me. Someone who's been kind of quiet today. You want to help me figure out A or X. Someone help me out.
Yeah, why?
Okay, come on.
Egan.
Come on. Someone help me. So who's been quiet?
Tanner. I've been
Yeah, I'm gonna use sine.
Great.
We should pull a stick.
No.
Yeah.
That's actually a good idea.
Yeah.
All right.
Let me pull it since I'm
Austin
just
is
pushing
very
it. Pull it.
better on.
I know.
Okay, so let's do this.
Number between 1 and 100.
Let's go with. I'm gonna go with Dakota on this. Okay. Dakota. I won't pick on you, but I am gonna go. Let's see. I just want to get one of my quieter students, Nicole. I'm gonna go with you. Okay. So Nicole, I'm not gonna make you do the whole problem. All you're gonna do, Nicole, is help me find A. Okay. So Nicole, help me find A. So what are you gonna do?
I did the sine of 67.5.
Okay, and you're using sine because you're using opposite over hypotenuse, right? Good, I like that. So sine of 67.5 equals what?
A over 11.
A over 11. Very good. Okay. Now, if you're using this other angle, you'd use cosine, right?
Yeah.
Which is fine. Okay, now, Nicole, help me out. How would I figure out A?
You would multiply both sides by 11.
Multiply both sides by 11. Okay, so now I know that A equals 11 sines of 67.5. Very good. Excellent job. Okay, Nicole, your job is done. Esme, help me out. How would I find X? Let's use 67.5 as our reference angle. So to find X, we're going to use this 11 again, and we're going to use this X. This is the adjacent side of that angle, right? This is the hypotenuse of that angle. What ratio uses adjacent over hypotenuse, Esme? Cosine, very good. Remember, if you've forgotten it, guys, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, see that? Okay, so we're going to use cosine. All right, so help me out, Esme. Cosine, so we're going to do cosine of 67.5 equals what, Esme? Equals x over 11. Very good. Now, we want to solve for x, right, Esme? So what are we going to do? Yes. So we get x equals 11 times the cosine of 67.5. Does everyone understand that? Okay. Are there any questions? Excellent. So now we have this x. We have a. Now, we don't really, I probably shouldn't have not have x boxed in x, because really I don't want x. I want what? I want 2x, but then I want, how many x's am I going to need to get the p? So p is equal to 16 times 11, right? What is 16 times 11? Do the math. What is it? What is it?
176.
Okay, does everyone understand where I got the 16 from? Because this little chunk from here to here is 1/16 of the perimeter. Do you guys see that? So that's going to give me what, Tanner, what was that number? So perimeter is going to be 176 cosines of 67.5. You guys see that? Okay. Now, these seems like really complicated, but really we're just finding simple numbers here. See, Nicole. All right, so now we're going to use our area. So our area formula is 1/2. I'm going to use 0.5 just because we're doing so much decimal stuff. 0.5 times, what's my A, class? 11 sines of 67.5 times, what's my P?
176.
Okay, sorry, that's in my thing. Okay, now when you multiply that out, we're getting, am I ever going to, I'm joking with Chris that he was like a little different than Xavier's by a decimal. Am I ever going to take points off on a test for that? No way. I would never do that.
I was
Okay.
off 0.7.
Okay, so can someone give me an answer that you got?
341.5 centimeters squared.
341 point what?
42 squared.
342?
No, that's my idea.
I got 342.7.
Okay, so
That's 0.20. What the heck?
So, what did you get, Xavier? Okay.
That's what I got.
It's
I
actually
agree with Xavier.
0.40.
Okay, now listen up. Okay, so if you got 342 point anything, you're going to get full credit on the test, okay? So now, if you got 341, you would not get the full credit. Okay, you get a little ticky top off. And then that's it, guys. Does that sound good?
Yes, sir.
We're done.
Oh, you need to stop your recording.
There you go. Good.
Sam posting your